Hey guys, this is Miss Regine from SOAR Educational Services. Today we're going to be working on some trigonometric or pre-calculus skills. It is to find the sixth trigonometric function of these given points. So when you're in trigonometry or pre-calculus, you do a lot of work with the unit circle. And they will give you these 2 points, or this, let's start with the first point. So you have this point, and with the unit circle, it works just like your regular quadrant. So 3, -3 would be right here, which is in my fourth quadrant. So this is this point, but now they want us to find the sixth trigonometric function for it. So what you have to do is you have to draw a triangle. Okay, so this is our point on our unit circle right here. The length here, or it's 3, which since this is our x, that's what we consider the sine. Down here it's -3. It is important to remember your negatives depending on the quadrant, because it does change your answer. All the answers are pretty much the same, except they're going to be like negative version of each other. So you do need to remember your negatives, because +3 and -3 are not the same thing. Now we don't know how long the hypotenuse is, and if you remember, to find some of the trigonometric function like sine and cosine, you need the hypotenuse. So we would have to use the Pythagorean theorem to find the hypotenuse. So a squared, which we'll call that the 3, plus -3 squared, and that's going to give us our c squared. So we have 9 plus 9 is 18, and sorry, let me write it right here. You take the square root, and it's 3 radical 3. 3 square root of 3. So some of you may have realized that, oh, this is a 45, 45, 90 triangle. It is actually 315 degrees, if you actually want to be specific, but it is a 45, 45, 90 triangle. Oh, sorry. It's 3 radical 2. Sometimes I do these too quickly and I forget stuff. But you could use a calculator. Like if you put the square root of 18, some calculators will give you 3 square root of 2. Some will just give you the decimal version. So it's good to understand how to break it down. I do have a video from before where I explain how to break down your radicals. So that's 3 square root of 2. Now, sine is, so I'm going to erase this. So if you need to take a picture or write it down, do it quickly. Now, if you're trying to find the sine of this, sine is opposite over hypotenuse. So, and this is our angle theta that they call. So our main angle is always right by the origin. So our angle theta, sine is -3 over 3 square root of 2. Now, there is an algebra rule that you cannot have radicals in your denominator. So you're going to have to rationalize your denominator. And the way to do that is to multiply top and bottom by the square root. So -3 square root of 2. And square root of 2 times square root of 2 is regular 2. So it becomes 2. 2 times 2 is 6. And when we simplify this fraction, we have negative square root of 2 over 2. So that's our sine. Now, the inverse of sine is cosecant. So the cosecant is the reciprocal of sine. So the easiest way to do that is to flip it. 3 square root of 2 over -3. Now, the 3's cancel out. So we can just say negative square root of 2. So that's our cosecant. If we're doing cosine, cosine is adjacent over hypotenuse. So do remember this is a 45, 45, 90. So you're going to see a lot of the same thing. 3 over 3 square root of 2. So we'll multiply that by square root of 2. And I'm just going to have the positive version, which was square root of 2 over 2. And secant, which is the reciprocal of cosine, we will do 3 square root of 2 over 3, which just gives us square root of 3 right here. And write tangent over here. So tangent is opposite over adjacent. So opposite is -3 over 3, and that gives me -1. Cotangent will be the same thing. So it's actually adjacent over opposite, but as we can see, these are the same numbers. So that's -1. So this is our first function, which is in the fourth quadrant. Okay, you can pause the video and try the other one and come back and let's see how you do. Okay, so let's begin the second one. -2, -5. This one may not be, this one's not going to be as friendly. So you have -2, -5. We still need to do the Pythagorean theorem to find out what our hypothesis, hypotenuse is. Okay, so -2 squared plus -5 squared equals c squared. So -2 to the second power is 4. -5 to the second power is 25. So that's 29. Write it this way. You take the square root, square root of 29. Now, square root of 29 cannot be broken down. 29 is a prime number, so it just cannot be broken down. So don't waste your time doing that. Try to memorize your prime numbers so you could know that. So now let's start with the sine. Sine is, so this is our angle theta right here. So this one I'm not going to be able to tell you like, oh, this is a 45, 45, 90, because it's just not one of the ones that we know like that. Now, you could use your calculator and using the inverse of any of those functions to actually find what the degree of that angle is. I don't have my graphing calculator here right now, so I can't tell you, but you could do like sine -1 of -5 over the square root of 29 to find what the actual angle is. Okay, so now sine, but that's not what we're solving for today. So sine is opposite, which is -5 over the square root of 29. Again, we have that radical in our denominator that we need to rationalize. So we have -5 square root of 29 over 29. Cosecant, which is the reciprocal of sine. So we'll have 29 over -5. And we could probably just leave it there. We'll just leave it there. There's nothing else to do here. Cosine is adjacent over hypotenuse. So take the square root, take the square root. So we have -2 square root of 29 over 29. Again, nothing can simplify them, so we'll just leave it as it is. Secant, we have square root of 29 over -2. And there's nothing else that we can do with this, so we'll just leave that. Tangent, we have opposite over adjacent. Well, negative makes a positive, so our tangent here is +5 over 2. And now cotangent is adjacent over opposite. Again, there were 2 negatives, but we can make it 2 positive. And so that's our cotangent. All right, guys, so this is how you can use just an ordered pair to find all 6 trigonometric functions. And this will be helpful in a trig class or a pre-calculus class. If you found this helpful, please like and subscribe, and I'll see you next time. Bye.